Hello, dear aspirants. Hope you are doing well and studying hard for your examinations. This is our contact number, which is 98367930076. Again, I am repeating it, which is 98367930076. And our email ID is saurabhsurclasses@gmail.com. Please feel free to contact via this contact details, and your preparation for any examination will be will be a very smooth way. So please feel free to contact via this contact details, so we can help you via one-on-one sessions and via conduct live classes and the doubt clearing sessions and etc. So please feel free to contact. Okay, so we are now solving a TIFR GS 2025 question. So this question appeared in the question paper, and the question is telling us that the number of real cubic polynomials of the form x cube plus ax plus b, each of those complex roots lies on the unit circle S1 is equals to z belongs to C, where our z bar is equals to 1, which is a circle, equals option A is telling us that option A is 0, option B 2, option C infinity, and option D is telling us that none of these remaining three options. So what can be done? So So the key properties of the roots, that means if all the roots of the polynomial lie on the unit circle S1, then what will happen? Then the roots must satisfy this thing. Mod of Z has to be 1. Okay. So the roots of the cubic polynomial will be what? That their sum. So since the polynomial is monic and this is on the form as this, so there is the coefficient of x square is 0, so sum of roots will be 0. Okay, this implies that the roots are symmetrically distributed on the unit circle. So now we are going to analyze the roots configuration. So the geometry of roots on the unit circle will be the roots z1, z2, z3 be the roots of, let us name it z1, z2 and z3. They are the roots of this equation. Since the sum of the roots is 0, the roots must form an equilateral triangle on the unit circle. This geometric constraint significantly restricts the possible configurations of the roots. So now the roots forming an equilateral triangle. Let the roots be omega, omega square and omega cube, which are where our omega is equals to e to the power 2 pi I by 3 is a primitive cube root of unity. We all know that. So these roots satisfy what? Our omega plus omega square plus omega cube will be 0. We all know that, and all the mods, that means mod, all absolute values are 1. Okay. So alternatively, the roots may be rotated version of omega, omega square and omega cube by multiplying them by a real number r, such that our r into mod zi is equals to 1. So now we are going to find the polynomial. So the polynomial whose roots are z1, z2, z3 can be written as, on this form we can see that p of x is equals to x minus z1 into that will be x minus z2 into that will be x minus z3. Using our z1 plus z2 plus z3 equals to 0, we can see that our px will be x cube plus ax plus b, where our a is minus of z1 z2 plus z2 z3 plus z3 z1. And our B will be what? B will be minus of Z1, Z2, Z3. Sorry, there will be no minus. Okay. Sorry. There will be minus of Z1, Z2, Z3. Okay. So now for the roots, that means Z1, Z2 and Z3, that will be plus. I have done something wrong. Okay. So the product of the roots Z1, Z2 and Z3 must satisfy, that is equals to 1. Implying our B equals to plus minus 1. So the term A, which depends on the pairwise products of the roots, will take on specific values depending on the configuration. So now we are going to enumerate the possibilities. So these are two possible polynomials that satisfy the conditions, which are these. That means our Px is equals to x cube minus 3x plus 1, and again the Px can be x cube minus 3x minus 1. There are, these corresponds to be the distinct ways to assign my B equals to plus minus 1 and maintaining the symmetry and required things. That means our Z1 plus Z2 plus Z3 is equals to 0 and mod of Zi is equals to 1. So the final answer of this equation, of this question, will be 2, because we are getting two polynomials that will satisfy all the things. Okay. So again I am telling that please feel free to contact via these contact details. Then we can help you by various manner or all the mathematical way of thinking to enlarge you by the mathematical thinking. Okay. So thank you guys.